For our project, we are doing a password activated circuit breaker. I am Chandler Enz.
And I am Duingo.
So this is the motivation for our project to deliver these three features um, to provide security, safety, and convenience. Security and safety will be implemented with the password activation. It will prevent unauthorized users from accessing the system and also prevent accidents from happening because it will be restricted. And then it will also provide convenience by showing the resources that you're using from the system and displaying that for you, and also providing a feature where you can see the all the information remotely through an IoT device. This is our plan for the design. It will follow kind of this flow that we have where it starts with the keypad interface where you input the password and it will show your password on the screen and tell you if it's right or wrong based on the digital logic. So that password will be entered through the keypad and then it'll be sent to the microcontroller, which will decide to activate the system or not. Once it's been validated, it will display the information to you on the LCD, like the energy resource monitor, and also you will be granted access to the system, and the information is handled through the microcontrollers, which will likely be a digital logic software program.
These are some constraints that we could think of at this moment that we thought for the project. The first one will be uh, the power source that we're gonna need for the system in case that we don't, in case that there's no solar power. So we're gonna need to have a secondary power source, like a extra battery store. Internet connection will also uh, be part of the limitation because of the limited connection that for the internet will always be accessible. And the last thing is um, the power the power of our system may not compatible with the other assistant power. So we're gonna need a power conversion to get the power input and output together. So the plan part that we're gonna use for our project, we plan to use STM32 microcontroller and ESP32 microcontroller. For STM32, that one will handle the password digital logic, and the ESP32 will able to handle the internet connection um, and power source um, management. If in future that when we able to research more microcontrol, there's another microcontroller that can handle both of those function. We will change to we will just use one microcontroller to have all the feature, and then we gonna also use the 4x4 keypad as an input into the microcontroller. We also have some of the software that we plan to use to code our device, and depend on which microcontroller we use, we will choose the best suit software to code on. So currently, this is the estimate cost for our project. Um, for the microcontroller, depend on how many microcontroller that we're going to use. The cost may be the cost may go down slightly cheaper than the estimate that we currently have, but overall, this is the best cost that we come up at the moment. Until further research, we we will have more extra miscellaneous stuff that we need to add in for in future. So our goal for the project, we aim to make it you more usable in different situation. Therefore, we want to aim for our project to have three different function compared to the other existing product in the market that does not have all of those three features that we listed in the table. Um, we also uh, we also want our scalability of our project to be high for the user.
So for our milestones, the process that we're going to take is to first research and plan our design, make sure that the components we're using are feasible and efficient, and we want the design to have the proper hardware that can implement the features that we want. For the password verification, we want to make sure that the keypad and the microcontroller and the display all work together and function properly, as well as the other features. We just want to make sure everything can be combined easily because each feature separately will be their own milestone, and then combining them together is its own milestone. So that will be a bulk of the process. For the wireless communication, we need to do a lot of research on how we can properly show the energy resources that we're using through a device, whether that's going to be through an app or like through an existing app, or if we're going to have to make a simple one, we still have to do more research on that. For the interface and display, we will do a 7 seg possibly for the password, since it's just displaying digits. And then for the LCD screen, we'll use the skills that we've gotten in embedded systems to be able to code the LCD display. And then implementing a prototype will be where we combine all the features and test it. It will not be a standalone system, so we need to have a like a source that we can test with it. Um, I guess we could just use a light bulb to test if the circuit is breaking or not. But it will be through a power source, so we'll want to test that as well. And then we'll just document all of our final findings and make sure we have schematics and a proper plan for everything. And then we'll be demonstrating the project that we have. This is a rough timeline for how we're planning to complete the project in the 2 semesters. Since we are a team now, we'll be able to overlap these processes a little bit, kind of multitask between the team members. It follows pretty closely with our milestones, so we'll kind of just go down the checklist, make sure everything's good. We did not a lot of time for testing, so that will probably need to be adjusted based on the problems that we encounter. But if everything goes smoothly, this is what we have planned for now.
So these are the class that we had taking or we plan to take in the future. But currently, we have most of the class that to enhance our knowledge for the project, like Micro 1, Micro 2, Digital System, and Embedded. For both Digital System and Embedded, we had done a lot lab and project on those two class, and those are relevant to our project that we plan to do. So we think that we have good knowledge to do research and do and make our project doable.
For our deliverables, what we want to accomplish with this project is to have a password system that will grant access through the password verification and make sure that is giving you access if you enter the password correctly. And then we will want to display the energy resources that are being used onto some kind of interface, like an LCD screen, and then we'll be able to interface with the system and see that energy tracking through remote IoT communication. And those are our main deliverables, and we'll follow pinouts and schematics that we design to accomplish those goals, and then test each of those features to make sure they work together properly. So in summary, for our project, we want to have our three main features to work together properly. We want the password entry to be verified through digital logic on the microcontroller and either grant access or not based on if the password is correct or not. We also want to display the resource tracking for the power system on either a separate microcontroller or the same one if it's compatible. We will also want to have internet communication through that resource tracking. We'll have to do more research to decide if we want to do that through an app or on the device itself. IoT should be capable of doing that kind of communication for a smart device. And we just want to have all these features working simultaneously. It's not a standalone design, so we'll have to test it through a light bulb for simplicity, but also we will want to test it through a power system since that's what we're designing for, to make sure it is blocking the resource from being obtained when the password is incorrect, and that it is converted properly to the system when the password is correct. Um, it is a scalable project, so it can be implemented into different sources and situations. And so we want to have a working design and well thought out and planned through the microcontrollers that we're using.